Hello everyone. This is the first of two videos dedicated to functional groups and chemical reactivity. In this first video, we will go through quite a few functional groups. Some of them are probably familiar to you, but others might be new, hopefully. And we will look at the classification of functional groups according to their level. And then in the second video, we will look at some typical reactions, some typical transformations to move from functional groups from one level to the other. I will start sharing my screen right now so we can make a start. These two videos are based on a chapter by Killer and Buthers from the book Chemical Structure and Reactivity, an Integrated Approach. And the book is, this chapter is scanned and is available on the Blackboard for the module. The aim of this first part of the recording of this first video is for you to learn to classify, first of all, to become familiar with a range of functional groups and also be able to classify them according to their level. And in a few places throughout the video, I will ask you to stop the recording and do the exercises yourself. And I will really encourage you to do that. I will give you the answer in the next slide. However, it is important for you to stop and try the exercises yourself. And if you have any problems, go back into the recording and look at the chapter too and see if you can do them yourselves. We will pick them up in sessions too, but please do stop the video when I ask you to. So a brief overview of organic chemistry is concentrated on carbon-based compounds. And the role of functional groups is an attempt to make sense of organic compounds. Functional groups are a set of atoms, a particular grouping of atoms that are repeated over and over again, and that they can be easily recognized in a particular structure. A way of classifying functional groups that you may or may not be familiar with is according to the number of bonds a particular carbon atom has to elements that have a high electronegativity. And then the functional group level is the number of those bonds. So when we are classifying a functional group according to their level, we look at a particular carbon atom and we look at how many atoms are attached to that carbon, either several of them or several bonds to the same atom, atoms that have a higher electronegativity than carbon. And we can classify reactions according to the change in functional group level. And you will see that we will be talking in this video and the next one, changes from level 1 to level 2, 3 to 4, 4 to 1, etc. And within a particular functional group level, within those levels, there is often a general order of reactivity for the different functional groups that belong to that level. And we can enact transformations from one functional group to another, and that can take place in the form of many mechanisms, and they will be the study throughout this module. We will be studying several of those mechanisms, and will greatly depend on particular reagents used and in general the reaction conditions. So how can you classify a functional group according to their level? You look at the carbon atom that you are interested on and see how many bonds has that atom, that carbon atom, to elements that are more electronegative than the carbon itself. So if it has only one bond to an element that is more electronegative, then we call that level 2. If it has two bonds, either to the same heteroatom or to two different ones, we classify that as level 2. If it has 3 bonds, again, or to the same heteroatom or to different ones, level 3, level 4. Why classify them on this way? Because when we are doing reactivity of organic compounds, it is often quite easy to replace one of those carbon heteroatom bonds to form another. So we can convert that particular functional group in a different functional group with another heteroatom, but at the same level. So here's an example of various reactions by bromobutane. And as you can see, with the same starting compound, bromobutane, and depending on what reagent we are using, we can produce an alcohol, an ester, etc. We will discuss these functional groups in the next slides. But the key relationship between all those groups, between all those chemicals, is that if you're looking at this carbon atom, in all cases, it has only one heteroatom attached to it. So all those carbons, all those compounds belong to the functional group level 1. So these are some examples of level 1 functional groups. And I'm going to ask you to stop the video now and try to come up with as many names as you remember from these functional groups. Hopefully some of them are familiar, many of them are probably familiar to you from previous years, from your previous studies. So pause the recording now and name those functional groups. Hopefully you have paused the recording as I asked you to do, and you have come up with probably similar names. We've got what we call some of the very common functional groups in these slides. We have alcohols, halocarbons, or haloalkanes. We have amines, primary, secondary, tertiary. We have ethers. You might or may not be familiar, for example, with epoxides, these ethers in a triangular structure, these attached to two carbon atoms, really, really interesting reagents. And for example, you might have heard about epoxide resins. You may or may not have been familiar with the hydroperoxides, or in general the peroxides groups, these OO structure. Or for example, sulfur groups. You may or may not have come across thiols and thioethers, where the functional group is the sulfur atom. In this next slide are some of the most common level 2 functional groups. And if you look at the carbon in red, you will see that in all cases that carbon is attached with two bonds to either one heteroatom or two. The ones at the top, both bonds are with the same heteroatom, the ones at the bottom with two different heteroatoms, but it's the fact that it has two bonds to an heteroatom, which is more electronegative than carbon, that makes all those functional groups level 2. So again, I'm going to ask you to pause the recording now and try to name as many of those functional groups as you can. Again, hopefully you paused the recording as I asked you to and gave these functional groups a name. Some of them are very familiar to you, I'm sure: ketones, aldehydes. Others, for example, like amines, you might not have come across. This carbon, double bond nitrogen, and attached to another carbon. Oximes, for example, carbon, double bond nitrogen, and attached to an OH. At the bottom, we have a collection of mostly oxygenated compounds. We have hydrates or gem diols. I confess I'm not very familiar with the expression gem diol and tend to call them hydrates. We've got a couple of versions of acetals. The first one is sometimes called acetal, or you can call them both acetal. This structure of the carbon attached to with two single bonds to two oxygen atoms in ether groups, either in an end in a terminal carbon or in the middle of a chain. And hemiacetal, in which only one of the oxygens is an ether group and the other one is a hydroxyl group. And finally, gem diahalides, when you have two halogens sitting on the same carbon atoms. And again, all those functional groups in this slide have this thing in common: 2 bonds to an heteroatom, or 2 that is more electronegative than carbon, and that what makes them level 2. Here, just on a slide to show you the variety of reactions that you can get when you are working with level 2 functional groups, and how it is relatively easy. Look at the conditions of these reactions: acidic medium, and in many cases mild conditions, not in all of them mild conditions, but in general you only have to heat them up in typically acidic conditions, and you can convert many of those level 2 functional groups into aldehydes or ketones. And if you follow, for example, the carbons with the dots in the original compound, like for example this one and this one in this imine functional group, you can see how the ring breaks, and you end up with a linear compound, and you end up forming a ketone. And here at the bottom, just highlight the very, very famous hemiacetal, which is the molecule of glucose. Monosaccharides are hemiacetals. These are again another set of functional groups. Some of them may more familiar to you than others, which are in this case level 3. And again, if you look at the carbon in red, you will see that this carbon has 3 bonds to heteroatoms that are more electronegative than carbon itself. And sometimes it's a combination of double bonds and single bonds, like in the top examples, and sometimes you have 3 different heteroatoms, although they're all oxygen, and sometimes you have the 3 bonds to the same heteroatom, like the group here in the center, the triple bond carbon nitrogen. And again, I'm going to ask you to pause the recording and try to name as many functional groups in this slide as you can think of. So if you pause the recording and look back at your knowledge of organic chemistry, probably some of those functional groups are quite familiar to you. Carboxylic acids are typical level 3 functional groups. We have esters, we have amides. Others may be less familiar, like for example orthoesters or trihalides. And the nitrite group or cyanide, I tend to call it the nitrile group, or for example acid anhydride, and I think you have worked in the past with acetic anhydride, which is for example typical to synthesize compounds such as aspirin. You might also be familiar with acyl chloride or acid chlorides, which are quite reactive groups and really useful in organic when conducting organic synthesis. This slide gives you an overview of typical reactions of hydrolysis, either in a neutral pH or a slightly acidic pH, in relatively mild conditions that combine different level 3 functional groups into carboxylic acids. And again, if you follow the red dot, which shows the carbon, the level 3 carbon, you can see where that carbon has ended in the final compound. And throughout this module, we will be exploring how these reactions happen. So this is just a general overview of the type of reactions we are going to be exploring throughout the module. And the final example of functional groups I have to show you is level 4 functional groups. And again, I'm going to ask you to stop the recording right now and try to name some of these functional groups. See if you know their names. This was probably the slide that had perhaps the most unfamiliar functional groups. It's a bit of an assumption in my case, but typically it's the ones that students tend to be less familiar with. And we have carbonates, we have the isocyanate group, we have urea, the molecule of urea, substituted urea. We've got carbamates and orthocarbonates. And in they might sound a bit odd. However, there are quite a few small molecules, important small molecules, that have these level 4 functional groups. And again, just if you count the number of bonds around that carbon, which is the center of the functional group, that carbon highlighted in red, you will see that it has 4 bonds to heteroatoms that are more electronegative than itself. And here there are some examples, for example, the famous carbonic acid, carbon dioxide, which could be arguably not be considered an organic compound, but we can, if we are slightly open-minded of how we define organic compounds, carbon dioxide would be one. The molecule of urea, for example, phosgene, guanidine. So there are quite a few important and interesting compounds, small molecules, that have these functional group, level 4 functional groups at the center. At the bottom, you can see the type of reactions that these level 4 functional groups have. And if we focus again, here is the carbon of interest, the one highlighted with the red dot, and how you can hydrolyze a carbamate group, and you end up producing an amine, you end up producing a molecule of CO2 and an alcohol. So you can break your molecule roughly down the middle, through the functional group, between the 2 bonds that join that sort of functional group, to the both sections of the molecule, and liberate the molecule of CO2. So finally, I'm going to, as the last exercise for this video, I'm going to ask you again to stop the recording, to look at the carbons that I'm going to highlight in red, and tell me, with this sort of red dot, and tell me what functional, what group level those carbons are. So please pause the recording now. I hope that it hasn't been too difficult to identify that this carbon has 1, 2, 3 bonds to, in this case, oxygen heteroatom, so it's a level 3 carbon. This one has only 2, so there will be a level 2 carbon. Here, if you look at the carbon I've highlighted, it's a carbonyl group. It's a ketone, and it's a level 2 carbon. And here you've got an example, the final one, an example of the isocyanate group, and would be a level 4 functional group. So this finishes this first part, and please join me in the second part of the video, in which I will talk you through some typical reactions of these functional groups and how we can move up and down functional groups. If you have any questions, please do let me know, or post in the discussion board, or I will pick it up in one of the sessions we are going to have together. So thank you very much for listening, and I hope this was useful.